All right. So when Schrodinger solved the wave equation, he solved for four variables. The very first variable he solved for was n. N is called the principal quantum number. And the principal quantum number actually indicates the energy level an electron is on. When you talk of energy level, you actually mean the distance the wave is from the nucleus. Is that right? If it's closer, it's going to have lesser energy. If it's further away from the nucleus, it's going to have more energy. Is that right? Isn't that how we come to the conclusion? Now, when he solved for n, there was a condition. N can have only whole number values. N can only be 1, 2, 3, 4, 5, etc. And how many total energy levels do we actually see on the periodic table? 7. Okay. Can there be more than 7? Yes. Are they allowed energy levels? Yes. But do we know of elements in which electrons actually occupy those energy levels? We haven't found them. We don't know of them. Does that make sense? All right? Now, so you have the n energy level. All right? Then he solved for NL. NL, he said, depends on n. All right? What values can L have? N can have values from 0, including 0, all right? It can have multiple solutions from 0 to n minus 1. Those are the possible values for L. And he called L the angular momentum quantum number, all right? And it indicates the shape or size of the orbital an electron is on, all right? So let's actually do what this means. Let's actually solve the problem, all right? So n, actually let me do it on a different page. Okay, so let's say n equals 1. If n equals 1, what are the allowed values of L? Well, let's do this way actually, so I can write it down like this. N equals 1. If n is 1, L can have values 0 to n minus 1. Is that right? What is the allowed value of L then? 0. All right? Say n equals 2. What are the allowed values of L? 0 and 1. If n equals 3, what are the allowed values of L? 0, 1, 2. Are we good? And we said n denotes the energy level. Is that right? What does L denote? The shape and the size of the orbital. All right? The shape and the number actually. When it is L equals 0, what do we know in the first energy level? What is the shape of the orbital? S. If L takes the value of 0, what is this region of space where the probable location is? It's now a sphere. So at energy level 2, again you have a solution of L equals 0. This indicates which energy level? 2s. That indicates which energy level? 1s. But L can not only be 0, but now L can be 1. Which means this is spherical, right? This is the spherical shape. This is also spherical shape. Now when we come to n is equal to p, what does the shape become? A dumbbell. All right? And so now it becomes the 2p. The principal energy level is 2, but if L equals 1, what is the shape of the orbital? It is a p orbital. Therefore, in energy level 1, you only have one s. When you go a little further away, you not only have the s, you also have the p. When you go a little further away, you can have the 3s, the 3p, and that will be what? The 3d. That's spherical. That's dumbbell. That's now a flower petal shape. Do you understand? So the L value indicates the shape of the orbital. What does it look like? Yes.
How did you know what they looked like? Like, how did you know?
Those mathematical calculations will give you the 90% probability distribution, and that when he plotted, he knew what it looked like. And that's why they're like these complex shapes that we can't even name in our everyday vocabulary. All right? So now we looked at, and then let's go and look at n is equal to 4. What are the allowed values if n is 4? 0, 1, 2, 3. Is that right? Those are the only allowed values. So that becomes what orbital? 4s, 4p, 4d, 4f. Are there more shapes than f? Sure. But we don't know elements that have so many electrons that occupy those orbitals. Do you understand? These things exist in theory. Now, let's go back to our page. And so now can have integer values from 0 to n minus 1, right? And then we say S, what is the value of L? 0. L equals 0 for an s orbital. If it's a p orbital, what is the value of L? 1. You should know this. All right? When it's a d orbital, what's the value of L? L equals 2. If it's an f orbital, what's the value of L? L equals 3. So then he solved for a different set of solutions. Now he came to MS, all right, not MS, ML, and he said ML now depends on L. All right? What are the possible solutions for ML? ML can vary from minus L, so to 0 to plus L. Those are the possible solutions for ML. So what did ML solve for? If L equals 0, there is no minus 0, 0 plus 0. It's only 0. So the sphere is like equally spread around the nucleus. All right? There is no orientation to it. Does that make sense? ML actually talked about orientation. Again, 2s, the orientation is 0. Means it's spread throughout around the nucleus. But when you come to L equals 1, the possible values of ML are minus 1, 0, and plus 1. It can go from minus L to 0 to plus L. Is that right? So now he says, well, since there are 3 different orientations possible, how many different p orbitals do we have? 3 different p orbitals oriented along the x, y, and z axis. How do you know there are only 3 p orbitals? Why can't there be 4? If you answer that question, it comes from his solution. You understand? Then you go into, again, this will be what? ML will be 0. This will be minus 1, 0, plus 1. When you come to d orbital, all right, L equals 2. So what are the possible values of ML? Negative 2, negative 1, 0, positive 1, positive 2. So how many different d orbitals do we have? 5. 5 different orientations. All right? And then similarly, if you go to L equals 3, you will have values ranging from negative 3, negative 2, negative 1, 0, positive 1, positive 2, positive 3, which makes it a total of 7 orbitals. Do you understand? So then, his last quantum number, let's see what we need to fill out in this, all right? The magnetic quantum number ml indicates which of the orbitals an electron is in and can have integer values from minus L to 0 to plus L. Right? And his very last quantum number was the spin quantum number. It indicates the direction of spin. The direction of spin of the electron. And it can have a value of plus half or minus half. Meaning it's either spinning in the clockwise direction or it's spinning in the counterclockwise direction inside an orbital. Alright? So if you actually go down here, you can have the final value, which is ms, can be plus half or minus half. How many total electrons can enter energy level 1? 2. What is the shape? It looks like a sphere. It's equally distributed. There is 1s energy level. Do you see that? It all comes from this solution is how we write electron configurations for the elements in the periodic table. Again, 2s is plus half and minus half. Again, if you go to 2p orbital, there's minus 1 is one of the directions in which you will find a probable location. Let's call this the px. Is that right? Within px, you have the plus half and the minus half. Within py, you have the plus half and the minus half. Within pz, you have the plus half and the minus half. In other words, he concluded that no two electrons will have the same 4 quantum numbers. Each and every electron will at least differ in one of their quantum numbers. Does that make sense? Which makes each and every electron unique inside an atom. Do you understand this? Okay? So now let's go and complete our notes here and see what we have. Alright, so let's see. When n equals 3, L can have values from 0 to n minus 1. What are the possible values of L? 0, 1, 2. Alright? 0, 1, 2. If it's a d orbital, what is the value of L? L equals 2. When n equals 4, what are the possible values of L? 0, 1, 2, 3. If it is a p orbital, what is the value of L? This is 0 as p is 1. If n equals 2, what are the values of L? 0 and 1. If it is an s orbital, what is the value of L? 0. Okay? So, summarize. When it's an s orbital, what's the value of L? 0. If it's a p orbital, what's the value of L? 1. If it is d, it is 2. If it is f, L is 4. Okay. Now, in a d orbital, there can be 5 different electrons. Is that right? Now, let's list. If there are 5 electrons in a d orbital, all right? This is 4d. All right? 1, 2, 3, 4, 5. You can have more, but there are those 5 electrons in the 4d orbital. For each of this electron, what is your quantum number? They all reside in energy level 4. All of them will have what? The principal quantum number n will be 4. They are in the d orbital. So what will the value of L be? 2. Alright? It's a d orbital, so L will be, this is L. This is n, right? These are L values. All of them are in d orbital, so all the L values are the same. What about the ML? ML ranges from what? ML goes from minus L to 0 to plus L. Meaning, what is each of these orbitals? What are these orbitals? Minus 2, minus 1, 0, plus 1, plus 2. They are in different directions. Do you see that? Their orientation is different for each of these electrons. Do you understand it? Alright? And if you want to write the spin, all the up arrows can be what? Plus half, all of them are up arrows. Is that right? Each one is spinning in the up direction. Is that right? Do each of these electrons differ at least in one quantum number?
Yeah.
They cannot be the same for any two electrons. Alright? So let's write out carbon's electron configuration. Carbon's electron configuration is 1s2, 2s2, 2p2. Do you agree? Let's write out the electron configuration for this first electron. What is the value of n? 1. It is in the s orbital. What is the value of L? 0. If L is 0, what will ML be?
0.
Automatically 0. Now, this electron is spinning up, plus 1 half. Alright? Let's do it for the next electron, which is, let me do a different color. Let's do a down spin. Alright? What is the value of n? 1. It's 0, 0, negative 1 half. Alright? Now let's choose this electron and do the quantum numbers for that particular electron in carbon. Alright? What do you think is the value of n? 2. It is in the p orbital. So what is the value of L? 1. Now, ML values can be what? 1 plus 1, 0 minus 1. You can give any of the three. We don't know which. They're equal energy orbitals. An electron can be here or here. Does it matter? Of the two electrons, does it really matter? It doesn't matter, right? They're equal energy orbitals. Give me any one. Either give me plus 1, minus 1, give me 1. Alright? I'm going to say it's minus 1. And then it's an up spin, so I'm going to say it is plus half. Do you understand this? Let's turn to the back. And let's review a little bit more of quantum numbers. Alright? Next class you will have a quiz on quantum numbers. What state the 4 quantum numbers? What are the 4 quantum numbers? N, L, ML, MS. What are the values of n? They can only be whole numbers, right? 1, 2, 3, etc. Whole numbers. L depends on n. What are the values of L? 0, 2, n minus 1 are the values of L. What are the values of ML? Minus L, 0 to plus L. What are the values of spin quantum number? Plus half or minus half. Okay? Now, so name the orbital. N is 3, L is 0. What orbital is this? Energy level 3, L is 0 means which orbital is it? 3s. N is equal to 3, L is equal to 1. What orbital is this? 3p. N is equal to 3, L is equal to 2. What orbital is this? 3d. N is equal to 5, L is equal to 0. 5s. Okay? Give the n and the l values for the following. Let's do this one. You do the remaining at home. What is the value for n? 2. What is the value for l if it's a p orbital? 1. Okay? What is wrong with the first set of quantum numbers? 2 is your principal quantum number. Can your L be the same as N? Can it be the same as N? It's N minus 1. At energy level 2, you do not have a d orbital. Does that make sense? L is equal to 2 indicates a d orbital. At the second energy level, you cannot have a d orbital. You cannot have that. That is wrong. The principal quantum number is 2. My 2 is the next quantum number. That's fine. It says it's 3D. Can you have a negative 3?
No.
No. It varies from minus L to 0 to plus L. That is wrong. What about this set of quantum numbers? This is 2. This is 1 less. This is 2 p orbital. Can you have minus 1, 0, plus 1 p orbitals? Yes or no? How do you know there are 3 orientation, Alex? Only because we say it's ML varies from minus L to 0 to plus L. All 4 quantum numbers are valid. This is correct. There's nothing wrong with this. Okay? Now, let's see. Let's choose a random one. I'm going to choose this particular electron, E. And I'm going to write out its 4 quantum numbers. It is in which energy level? 3. So what is my principal quantum number? 3. If it's a d orbital, what is the value of L? 2. What is ML? You can give it as minus 2, minus 1, 0, plus 1, plus 2.
I pledge allegiance to the flag of the United States and to the republic
Which stands one nation under God, indivisible, with liberty and justice for all.
Please pause for 1 minute of silence.